Okay, so find the volume of the air inside the letterbox is where we're at. So the volume of that, if we think back to our formula, what formula are we looking at there, Luke?
Well, length comes with
Okay, so remember that if it's a pyramid, a prism, sorry, if it's a prism and we're looking for the volume of that, what we can do is find the area of the cross section. Times by the length. Okay? Does that ring some bells for you? I know we've had a few days off. So area of cross section. Alright. So what shape is part of our cross section, or is there two sections that we might have to work from there? Ryan?
rectangle and triangle.
Absolutely. There's a rectangle through there. Alright, and I seem to remember last week saying to you, think of things as a block of cheese, and if you're able to slice through and it had the same consistent face, then that's the area of your cross section. Okay, so here for this part of the shape, or this part of the letterbox, we would be working out the area of the cross section through there. Okay, and multiplying it by the length. Is that okay? All right, that would give us the volume of that rectangular prism, yeah? And bear in mind, a prism means it has the same shape. We've been through this, but it has the same shape down one end as it does the other. Okay, remember we went through that some weeks ago? All right, has the same shape this end as it does this end. All right, it's the pyramids, remember, that come to a point above the base. Okay, so do you remember the difference between a prism and a pyramid, you guys, that are concentrating? Yeah? So once we got the volume of this shape here, we're left to choose that we need to do this shape through here, don't we? And add them together. All right. So what shape do we have there, Harry? What shape? We have a triangle. Okay. We have a triangle through there. And again, we use area of cross section times by the length. Okay. This would be our cross section, yeah? Because no matter how many times we slice it through there, we're going to still end up with a triangular shape. Okay. Now, the area for that, if we determine that the right angle is in there, then if we were to flip that over, we have a shape that looks like that, don't we? Where that is 15 and that is 15. Yeah? What formula do we do for area of cross section? Half the base times the height. What's the base? So you half 15 times it by 15. Okay, that would get you this here. And what do we have to do after that? We have to multiply by the length. So multiply by this distance here, which we know must be the same distance as through there, which is the same distance as this here because of these lines, meaning 24. So we're multiplying all of that by 24. All right? That's going to get you the volume of that. Ryan, it's really important you pay attention if you're choosing to. So that will give you the volume of that top bit. This over here will give the volume of the bottom bit. When you add that result to this result, you're going to get the total volume for that letterbox. Would you agree?
Yeah.
Yep. Then it says, if we go back to our question, if we can do that. If we go back to our question, it says that there are 3 rectangular envelopes with dimensions 23 by 12 by 5. Okay, so notice that this is centimetres, whereas this is millimetres, and this is centimetres. So you're going to need to do some conversions there. All right, and what might you need to do here with the 3 envelopes, Jake? Yeah, before we take it away, what do we have to do with these numbers here? There's some pretty important numbers there. We've got to find the volume of the 3 envelopes. Okay? So in this part of the section, question in B, we've got to find the volume of those 3 envelopes. And then, as Jake, you've said, we've got to subtract it from all of these calculations that were done up here. Okay? So in part A, we found the volume of the letterbox. In part B, we're finding the volume of the 3 envelopes and subtracting it from the letterbox because it says what volume remains inside the letterbox. Once you put those letters in, how much volume remains? So it may have started like this. You put 3 letters in, it's now reduced to that. We've got to subtract, yeah? Okay. Can I explain that any better for anybody? Ryan, do you understand that?
Yeah.
You feel like you do? Okay, I'll leave you with that to thrash away yourselves and see how you go. Okay, so there's cylindrical jars, so we know it's a cylinder of jars with external radius 3 centimetres, and a height of 10. Okay. He needs to cover the curved surface, and we know that the curved surface is 2 pi r/h, yeah? Alright. We therefore know 2 times pi times 3 times 10 would give us that curved surface area. 188.5 squared centimetres. So we're looking at surface area. If he has 2 square metres of sticky tape, so sticky paper, 2 square metres. So what's 2 square metres into centimetres? Well, that's what you need to know. So you go scroll back up and use your conversion charts, which is a long way back. So we're looking at square metres with, that's even further back than that. So have you gone back to your conversions, your area conversion charts on the previous chapter? Do you have them in close proximity? Yeah. So that leaves you with 20,000 square centimetres divided by 188.5 gives you what? 106 sticky labels could be made, which is what the answer was.
I just converted it wrong.
Why not?